In this example, we have f of x equals negative 1 over 3x to the third plus x squared plus 3x plus 1. Part A, we're going to find the critical values of the f, and part B, use the first derivative test to find any local extrema. To find the critical value, we're going to use the derivative. So I'm going to put a note here to find the critical values. So we're going to start with finding the derivative. And then um, let it be 0, or another case, find the case that undefined. So I will tell you the tip and trick real quick before we work on the detail of these two cases. Basically, you're going to find out what is f prime. The f prime is negative 1 over 3 times 3x squared for the first term plus 2x for the second term plus 3 for the third term, and then 0 for the last term. Simplified to be negative x squared plus 2x plus 3. Now we have the f prime expression, and this is the polynomial function. So when you determine the critical value, you're going to have two cases. So I'm going to write it out. Um, for the case of the f prime x equals 0, and the next case, the f prime of the x is undefined, because the critical value will come out from these two cases. Which one we're going to consider, or we consider both of them? Let's see the f prime that we have. This is a polynomial function. The polynomial function is defined everywhere. So we will not consider the case of the undefined because it's not applicable for this problem. So what we're going to do, we're going to write the f prime and then let it be 0. Solve for the critical value, which means we just consider only the case that the f prime equals 0, or the case that the tangent is horizontal. Okay, so we're gonna have negative x squared plus 2x plus 3 equals 0. And then to solve for x, factor negative 1 out, we have x squared minus 2x minus 3 equals 0. Factor one more time, we have x times x for the x squared. We have negative 3 times positive 1 to get negative 2. Now we get the two critical numbers, x equals 3 and x equals negative 1. With this step, we can say that the critical value are, we have two of them, are x, which is the c value, right? Equals 3 and negative 1. So we got two numbers. Part A is done. Next, in part B, we're going to use the first derivative test to find the local extrema. For part B, the first derivative test said when you draw the line, or it's called analysis line, you draw the C, or locate the C or the critical value. If the sign change from positive to negative, this is a sign of the F prime. If change from positive to negative, this is the case that there is the local from increasing to decreasing, right? So you're going to have the local max. For the case at the point C, the sign change from negative to positive, or the sign of the F prime change from negative to positive. This case is going to give you the local minimum value. As you analyze by the graphical way, the left-hand side of the critical point, the graph is rising because the slope is positive, and then the graph is falling, the slope is negative. You see the highest point occur at C because the slope is 0. And that point is called the local maximum, where the graph is falling down for the second case and then turn back to the rising graph. So we can see the lowest point or the local minimum occurs at C. And this case will give you the local minimum. So this is about or the quick summary for the first derivative test. So from what we have, we can go see the figure together later in a bit. So let me work on the detail. So I'm gonna put this away. So cut for now, um, just to minimize the confusion. So to use the first derivative test from the function f prime that we get in the most factor form, which is negative of the x minus 3 times x plus 1. So we draw the real number line. We locate the two critical values. They are negative 1 and 3. And this is the f prime, negative x minus 3 times x plus 1. So you're going to pick the value, any value on the right side of the x equals 3. For example, if x equals, pick the number 4. So then the f prime gonna be, we just analyze the sign. So negative sign, and if x greater than 3, the first factor gonna return plus sign, and then greater than 3 plus 1, you're gonna get another plus sign. So overall, you have negative sign for the f prime for the right open interval. And then for the middle one, if you take any value of the x between negative 1 and 3, let's pick the easy number like x equals 0. The f prime at the point 0 going to be negative from the front one here, and then 0 minus 3, that's the negative sign. 0 plus 1, that's the positive sign. The overall sign of the product going to be plus sign. So the middle factor, the middle interval going to return plus sign for the derivative. And then the leftmost interval, pick the value that is less than negative 1. For example, x is negative 2. If x is negative 2, the derivative or the f prime going to be negative multiplied by negative 2 minus 3, that is negative 5 or negative sign. Negative 2 plus 1, that's another negative sign. So overall, the f prime going to be negative for this interval. Now, we complete the sign for each open interval within the real number line, and this part is called the sign analysis. And then we can see that at each critical value, at x equals negative 1, the sign changing from negative to positive. And then at the point x equals 3, the sign change from positive to negative. Okay. With this way, we can see that at x equals negative 1, we're going to get the local minimum value is f at negative 1. And at x equals 3, we see the graph rising and then falling down. So it will occur the local minimum or local maximum, sorry. So then the local maximum, this is minimum, value is the function at 3. And then how to compute the numbers, we just plug it in the calculator. So f at negative 1. Recall this is the f, not the f prime. You have to go back to the original function form, which is negative 1 over 3 x to the third plus x squared and so forth. So I'm going to write down here. Which is negative 1 over 3, negative 1 to the third, and the second term is x squared plus 3x plus 1, x squared plus 3x plus 1, and the next function value f at 3 is negative 1 over 3 times 3 to the third minus, this is x squared, right? So going to be 3 to the second plus 3 times 3 and then plus 1. So that's what we have. All right, so make sure we don't mess up with the sign. And whatever the number that you get from the calculator, that's the y value. And I'm gonna bring the graph that I took away for a second. Uh, okay. So as you see the graph here, I'll bring it to the back. Bring. At -1, the function value is -2/3. At +3, the function value is 10. So with the graph, at -1, we have the horizontal tangent, and it gives you the local minimum value. Local minimum. At x equals 3, we have the local maximum value. And the order pair, which is the order pair x comma y, is the order pair when x is 3, y is 10. When x is -1, y is -2/3. If you talk about the value, gonna be just the y value. If you talk about the point, it's gonna be the order pair because the point is represented by the order pair. From the left side of the x equals -1, the graph is decreasing. The graph is decreasing because the negative slope between -1 and 3, or between the first critical value and second critical value, the graph is rising. The graph is rising. And then the right side of x equals 3, the graph is falling down, or the sign is negative. So we get a complete graph as what you see on the diagram there.